Hi, my name is Muhammad IMRAN bin ROSLI, and my number matrix is 202, 465, and 4044. This is the question. Let's find out the question first. The connection of two push buttons, switch 3 and switch 4, adds external LEDs display and one buzzer are shown in figure Q1. Write and execute C++ program using Arduino IDE for the RP2350 based market-IP microcontroller that will operate the following patterns. For patterns A, switch 3 is pressed or LEDs blinking in 1 second and buzzer on for 2 seconds. For pattern B, switch 4 is pressed, even LEDs on in 2 seconds and buzzer on for 4 seconds. For pattern C, both switches are pressed, all LEDs blinking in 0.1 second and buzzer on for 3 second delays. Load the program into the microcontroller and explain the result using a stopwatch. Prove the time delay for on and blinking LEDs, and this is a schematic diagrams. And at the middle, as you can see, there's a microcontroller which is RP2350, and there's a LEDs, 8 LEDs that connected with a resistor. And it's supposedly that what I have learned is supposedly 330 ohm, and there's a buzzers, and there's a switch 3 and switch 4. Basically, we were given a task involving two push buttons, switch 3 and switch 4, connected to a microcontroller RP2350, along with X external LEDs and buzzer. Then we need to try a C++ program using Arduino IDE that responds to three different patterns conditions. First pattern or condition when switch 3 is pressed, the odd numbers LED blinks every 1 second, and the buzzer turn on for 2 seconds. The second one, when switch 4 is pressed, the even numbers LEDs turn on for 2 seconds and the buzzer on for 4 seconds. The last one, patterns, when both switch 3 and switch 4 are pressed at the same time, all LEDs blink rapidly every 0.1 seconds and the buzzer stays on for 3 seconds. And our lab have three main objectives, which is the first one, we aim to design both the hardware and software of an input-output system using the RP2350 microcontroller, incorporating with two push button, LEDs and buzzer, all programmed in C++ through the Arduino IDE. The second one, we will build a working prototype by wiring all components to their design in GPIO pins according to the circuit diagram shown in figure Q1, then uploading the program onto the microcontroller. The last objective, we will test and troubleshoot the system by confirming the each button condition, produce the correct LEDs, blinking pattern, and buzzer timing using a stopwatch to validate the delay match what was programmed.
So I will explain about the flowchart. Firstly, it will read the SLB3 and SLB4. If SLB3 and SLB4 is pressed, that means both of the switch is pressed, then all the LED will blinking 0.1 seconds and the buzzer will on 3 seconds. If not, we will enter to the situations where SW3 is pressed. If yes, the odd LED will blinking 1 second and the buzzer will on 2 seconds. And if the SW3 is not pressed, then we will enter to the SW4 is pressed, which is the even LED will blinking 2 seconds and the buzzer will on 4 seconds, and the program will end or it will still reading SW3 and SW4. So let's get into the coding part. Firstly, we will declare the pin for SLP3, SLP4, and the buzzer. For SLP3, we will using 20 pin, pin 20. SLP4 is pin 21, and the buzzer is 18. Uh, and we will declare the pin for the all LED starting from GPIO 0 until GPIO 7. And we will set the timer for the LED and the buzzer equal to 0 for the initial. For this part, we will making the loops I0 until I less than 8, because we want to set the all 8 LED. And as we can see, the buzzer and the LED, we will just set it to the low condition, which is.
Okay, next I'll be explaining about the odd LED as bull state, even LED as bull state, and also the all LED as bull state. For the odd LED as bull state, the goal is to control the odd numbers for the pin for 1, 3, 5, and 7 using true or false state, meaning it's either in on or off state. So it will explicitly forces all the even pins 0, 2, 4, 6 to low, and it will be the safety feature to clear out any leftover lights from the previous modes so the patterns don't blend together on the hardware. For the even LED as bull state, it controls the even numbered pins 0, 2, 4, and 6 using the incoming state. It will officially shut down all the odd pins 1, 3, 5, and 7, and it will convert it to the even to low state. So it's just like the odd function. It will guarantee a visual transition when user switches the mode. For the all LED as bull state, it will controls all the 8 LED as at the same time, and it will use the for loop to automatically count from index 0 until 7. So instead of writing 8 separate lines of code, this single loop sweeps through the array in microseconds, and it will be easier to maintain the code. For my second part, I'll be explaining about digital read SW3 equals to low. For this code, it will the hardware will switches the wired active low, which means that the electricity will set to 0 volt, and it will only does that when the button is physically pressed. This code will check if the pin is low, and if it pressed, it will converts this hardware signal into true state inside the variable SW3, and if it's released, it will turn into false. For INT new mode, this create a blank temporary storage container. Its only job is to hold the mode number if we decide to go to the next step. For the next code, we have if SW3 and SW4 new mode equals to 3. It will check if both switches are pressed simultaneously, and if it's true, it will assign the mode 3, and it will establish a priority system. If we put individuals button check first, the pressing both button will accidentally trigger mode 1 or 2 instead. For else if SW3 new mode to 1, if both buttons are not pressed, it will only check if the switch tree is active or not. If yes, it will set mode 1. Next part is else if SW4 new mode to 2. If switch tree isn't pressed, it will check if only switch 4 is active. If yes, it will set the modes to 2. And lastly, we have new mode else new mode to 0. If no buttons are pressed, means that it will drop into safety net, and the default mode will set to mode 0, which represents the ideal mode.
Now let's look at mode 2, which is triggered when only switch 4 is pressed. The condition is if in bracket mode 2 checks that we are currently in mode 2. Inside, if in bracket now LED timer less than equals to 1000, checks whether 2000 milliseconds, which is 2 seconds, have passed since the last LEDs. If yes, LEDs equals to LED state, flips the current LED state So if it was on, it becomes off. And then even LEDs in bracket LED state applies that nested to the event numbers LEDs which are GP0, GP2, GP4 and GP6. LED timer equals to now, it will reset the timer so the next 2 seconds count begins fresh. And for the buzzer, if in bracket buzzer started and now buzzer timer less equals 4000, it will check if the buzzer has been running for 4 seconds. If yes, digital right buzzer low, turns the buzzer off, and buzzer started equals to false, it marks it is no longer active. And we will go to the next mode. For the mode 3, both switch, which is switch 3 and switch 4, LEDs fast blink, which is mode 3 handles the case when both switch and switch 4 are pressed at the same time. The condition F, if in bracket mode equals to 3, confirms we are in this mode. If in bracket now minus LED timer less equals 100, it will check if 100 milliseconds have passed, and it will create the rapid blinking effects. The next LED state equals to LED state, it toggles the LED state every 100 milliseconds. And after that, all LEDs in bracket LED state then applies that state to all the 8 lights, all 8 LEDs simultaneous, making them blink together very quickly. The next one, LED timer equals to now, reset the timer for the next 100 millisecond cycles. And for the buzzer, if in bracket buzzer started and now buzzer timer less equals 3000, it will check if 3 seconds have elapsed since the buzzer started. If so, digital right buzzer low turns the buzzer off, and buzzer started equals to false, and buzzers sequence. That's it for me.
For the discussion part, in this experiment, it was written 100% in C++ using Arduino IDE. It was loaded into RP2350 Maker PIP board. When the SW3 is pressed alone, the odd LEDs will blink 1 second interval, while the buzzer will sound 2 seconds. And when the SW4 is pressed alone, the even LEDs will turn on for 2 seconds and the buzzer will sound for 4 seconds. But if the SW3 and SW4 is pressed simultaneously, all the 8 LEDs will blink rapidly for 0.1 second intervals, while the buzzer will stay on for 3 seconds. Stopwatch measurements verified that the hardware execution is perfectly matched the program delays. This is negligible variables which cause the manual timing reactions limit. Overall, the system responded exactly as expected, and no software or hardware faults encountered during the demo. In conclusion, for this experiment, it successfully demonstrated the multiple inputs and outputs for RP2350 based Maker PIP core. The board is programmed via Arduino IDE. By utilizing the conditional logic of the microcontroller, precisely executed these 3 distinct hardware patterns based on the states and switches of SW3 and SW4, accurately driving the 8 LED array and the piezo buzzer. Stopwatch verification confirmed that the physical intervals for the LED blinking and buzzer operations align perfectly. with the program delays of 1, 2, 3, and 4 seconds. Ultimately, the integrated hardware RC filters ensured the stable switch inputs and the entire system functioned reliably without any coding or wiring errors. Thank you.